Right, maybe with a bit of luck this time, this will actually record voice. I have improved this script. Made some changes here. It's now asking for all of these variables rather than just assuming them. And those lines like east equals rad east, angfir equals rad angfir are converting from degrees to radians. So you now put your numbers in degrees. Have to use capitals because it's BBC Basic. Having got them, degrees and, well, meters. Actually, it'd work fine if you worked in feet. There's no reason it can't work in feet. It's then going to do all the maths as before. It's not bothering to print the north, east and down coordinates. I've renamed them. I've named them down correctly this time. It's calculating them all as before. So in each case, it's radius for the Earth times the sine of the angle is how far north it is. Radius for the Earth times the sine of how far east this row of ships is times the cosine of how far north of you this particular ship is how far east of you the waterline of this particular ship is. Radius for the Earth plus your elevation above it minus radius for the Earth times the cosine of how far east of your line of ships is times the cosine of how far north of you this particular ship is how far below you the waterline of this particular ship is. And for, the distance is of course the square root of the sum of the squares of those three. And the dip angle is the arc sine of how far down it is divided by how far away from you it is, because that's the straight line distance is the hypotenuse of a right angle triangle here. And then it does the same for the gunwale, the superstructure and the funnel, just adding their heights to the radius of the Earth for the calculations. Capital. And finally it prints everything out in a single line, and it's printing out where it says deg angle, deg bearing, that is converting back to degrees for the output so that you can see what's going on. It does still have $8 equals get dollar to request to force a pause, but instead of swamping the screen, it's only going to take up a couple of lines. Go 160 meters up and we'll go 0.1 degrees. This is the one that I put on XKCD. 0.1 degrees from the OP is the nearest point on this line. That's how far east of you it is. And we'll start due east of us. Angle between positions 0.01 degrees, not radians. Much bigger numbers when you're working in degrees. And we'll go 5 degrees away, which is well over the horizon, with an Earth radius of 6,378,137 meters, which I just typed into the number pad, which never existed on BBC Micro and therefore didn't register on the screen. 6378137 meters. I originally went 10, 20 and 40 meters here. I'm going to modify the ship. This one's going to be bigger. 15 meters to the gunwales. It's huge. 50 meters? That's insane. 40 meters to the top of the superstructure. This thing is immense. And funnels at 80 meters up. Good grief, this ship is tall. There's your horizon dip angle from 160 meters up. 0.4058 degrees. And that's all your positions when it is not very far away due east of you. That's all your dip angles, sorry. Angle 0 is the actual internal variable angle, which is how far north along that line this ship is. Bearing 0, it's a bearing east from a bearing north from due east, not a bearing east from north, because otherwise you get that division by 0. And then you've got your dip angles, all of which are more than 0.405. Even the funnel is below the horizon. And the next one, yeah, thank you for that angle. That's a really beautiful angle there. Yeah, it converted to radians and back, and it didn't quite get it right. Anyway, your bearing has gone to 5.7 degrees north, and the dip angles have all decreased. This thing is higher on your screen as it gets away from you, because it's getting closer to the horizon. And then as before, you can see that those dip angles all increase. And they're going to keep increasing until the waterline dip angle gets to about 0.40583. Yes, approximately a number to 5 decimal places. What this isn't showing is the actual distance to the horizon or the distance to the ship. You'll just have to, you know, 40584, and it's gone back down, 40587. Dip angle has increased. The ship is now going back down in your field of view on your screen if you're filming this, because it has gone over the horizon. So, yeah, 0.3999 off to infinity, 0.4 degrees. North of you, north along a line that is 0.1 degrees east of you, which is not quite the same thing. That ship has just gone over the horizon. The other parts of it, gunnel, superstructure and funnel, are still above. And if you keep going, .40569, 40804. The gunnel has now gone over the horizon. You can no longer see the hull of the ship, but you can still see the superstructure and the funnel. And that will be the superstructure going below the horizon, but the funnel's still visible. And that will be the funnel going. At 0.69, really. 0.69 was the first position where the funnel was invisible, and the 0.61 for the superstructure. Start again. Move the observer up. It was at 160 meters. Let's move him up to 400 meters. Put in the same things. What the heck did I put in? What did I put in? This is embarrassing. Should have written it down. 15, 40 and 80? Anyway, there's your greater horizon dip angle because you are higher up. And there's your first position with all the angles greater than that. I'm just going to hold down a key for a while. It's running a BBC Micro at 0.97, 0.99% of how fast it really could have done this. I put an awful lot of key presses into it, and it's just kind of work its way through the buffer, doing one line at one position at a time. Decrease in the dip angle to the waterline each time is getting smaller, isn't it? It's getting close to 0. 644, 643, 6426, 6421, 6418, 6417, 6417 again. That has just increased. That is the point where it goes over the horizon. We're already at 0.64. The angular position, 0.64. Before the waterline goes over the horizon from up here. And this is reminding you what your horizon is, the lowest value of the waterline dip angle. 0.64167, something like that, wasn't it? Notice by the time it's out there, the dip angle to the gunnel is very similar, because it's such a long way away, the angular size of the height of this ship is quite tiny. Point 64. 6417. That will be the gunnels going over the horizon. 0.76. And there goes the superstructure at 0.84. Funnel still visible. From this far up you can still see the funnel, even though it's gone that far north. Not anymore, you can't. But we're all the way out to 0.93 this time. If I put the observer all the way down at 5 meters above sea level, same 0.1, 0, 0.01, and well, you don't even need to go past 1 degree, do you? 5 degrees. Earth radius 6378137, and I'll have the same 15, 40, and 80 as last time. The horizon dip angle is now tiny. That E negative 2 is times 10 to the minus 2, otherwise known as divided by 100. So it's 0.0717 degrees. Let me write that down somewhere. Notice that the waterline here is still below that, plus 7.57 degrees dip angle. The gunnel is at minus 1.47774 degrees. It is, oh hang on, E minus 3, my mistake. The waterline is at 0.0757 degrees below eye level. The gunnel is at 0.00148 degrees above eye level, because you are only 5 meters above sea level and this thing's not very far away. Superstructure is 0.13 degrees above eye level, and the funnel is 0.336 degrees above eye level. Dip angle to the waterline is more than the dip angle to the horizon, and it's increasing. Even in the very first step, it's increasing. Which tells you, even without having the distances on screen, that even that close, that ship was already over the horizon. You've got a while to wait for the gunnels, though. They are below eye level now. The gunnel's gone from minus 0.00098 to plus 0.00050. So it's gone below eye level at 706. What the frick have you done to the angle? 2e minus 2, sorry. So 0.02 degrees northwards along that line, the gunnels are below eye level. But if you look at superstructure and funnel, they still have negative dip angles. They're still above eye level. If only this thing would display in, 160 column width, this would be so much easier to read. 2.9 times 10 to the minus 2. Looking for 7174243. 71743 times 10 to the minus 2, yeah. There we go. That's gone past 7.1743 times 10 to the minus 2, and we're only 0.17 degrees north of where we started. Superstructure is that's times 10 to the minus 3. I thought it was a little bit wrong there. Gunnel at 7.25, superstructure 7.27. What's going on? But it's times 10 to the minus 2 times 10 to the minus 3. That is 0.00727 degrees below eye level. And the funnel is still 0.00148 2.0971 degrees above eye level. Told you this was a tall ship. And there goes the superstructure below the horizon, and the funnel below eye level, 0.26 degrees. You'll see that at this distance, the rate at which those dip angles increases has increased from where it was when it was only just over the horizon, because it's a curve. It is, relative to where you are, getting steeper. Now it's still level where it is, but it's tilted further and further from level where you are. And there it goes, funnel below the horizon at a mere 0.35 degrees. And if you really want a silly one, put yourself up, mount tube cal with a very steep side right next to the ocean, and in the interest of speeding things up, I'll take bigger steps, 0.05, not 0.01, and we'll go to 10 degrees, not that we're going to have to. 6378137, and we'll have 15, 40, and 80 for sake of consistency. No, it won't. Yeah, it will. Heh, let's be silly. Let's have another tube cal. 4,000 metre high funnel. So from up here, the horizon is a whole 2.03 degrees below eye level, and the ship is most of 20 degrees below eye level, although the funnel, being 4 kilometres high, is just 0.05 degrees below eye level. What you'll see here will be all of these angles decreasing as the ship gets higher in your field of view as it gets nearer to the horizon again. Bearing in mind I'm taking bigger steps here. We're heading for 2.0287. 2.02865 if you fancy memorising that many digits. It was rising quite fast as it came out, pretty much out from underneath us going to the distance. It's not getting high in the screen as fast anymore. 2.085, 2.071, 2.059, we're almost there. .28882 versus 2879. That's pretty much on the horizon. It's already a whole 2 degrees north of us to get onto the horizon there. And there it goes below the horizon. Waterline below the horizon. And I think that's the gunnel following it just there. And that's the superstructure gone below the horizon. The funnel is below eye level. It has been below eye level the whole way. And it's a very long way below eye level, 1.3 degrees. Compared to the tiny numbers we had from lower observation points. What is it? 2.02856? Good job I didn't tell it to stop at 5 degrees. There we go. It's there at 4.1 degrees north. It's the funnel finally disappears by the other 4 kilometre high mountain finally disappears below the horizon. And by now the bearing to it is hardly changing, because of course it was only 0.1 degrees east of us, and is now, well, it's up to 5.7 degrees north, so it's pretty much due north of us, and pretty much going straight away. It's still slightly to the east. It's not exactly due north, but it is going almost straight away from us, so the bearing to it is hardly changing. And there you have it, the script that allows you to do 3D modelling of ships going over the curve in BBC Basic. It helps know when to let go of the shift key. That's all the calculations. It doesn't include refraction. If you want a simplified version of refraction, set radius to something like 70 million or 80 million. But that will do angle outputs on screen, which you can use as coordinates to plot the positions of the ship at those various points. If you download and install GIMP, you get coordinates on the screen. You can use the pencil tool and just watch the coordinates and click the appropriate points and draw lines from point to point for waterline, gunnel, superstructure, funnel, and you will get a set of lines curving over the horizon. Oh, draw a line across the screen at the horizon dip angle as well, obviously. And that will give you a set of lines going up to, curving over and dipping down behind the horizon. And if you scale it sideways to get it sort of, compressed into quite a narrow image, it starts looking a lot like Soundly's Lake Pontchartrain power line photographs.